It's a great pleasure that I now invite one of the leading brain experts in Denmark to give a presentation about the link between brain health and quality of life. Truls Skjær.
Thank you very much. And thanks a lot for inviting me to come here and talk about the most fascinating topic, the brain plasticity. The thing that the brain can change based on demand. And I want to talk about the brain health and compare it to quality of life. First of all, this is a brain. This is a real brain, not just an MRI. And if we look at a brain like this, we have 100 billion neurons. These neurons, they meet in synapses. And here we have a synapse, first neuron, second neuron, electrical signal coming down, release of neurotransmitter from these vesicles, these balls, that goes out to the surface and binds to the blue receptors on the next neuron. It is important here to remember that we have two types of blue receptors. We have those that make electrical signal into a new electrical signal in the other neuron, and we have those that make electrical signal in the first nerve into changes, modifications, structural changes in the synapse. The first thing is important for short-term memory, thinking, etc. The change of synapse structure, that's important for long-term memory, learning, etc. So let's have a look at that in details. And these are the neurotransmitters, approximately 200 of those, 1,000 of these per neuron, and 100 billion neurons. So my job as a clinical neurophysiologist is to try to figure out what happens in here in the yellow area based on input and output. So I have the standard 5 senses that I can use to test the patient, and then I have electrical coils and stuff to modify the brain action. And out comes motor output, conscious motor output, and the unconscious motor output, like sweating, pupil dilation, etc., etc. And then, of course, I can measure it with EEG and other methods. If we look deep into the brain, we know that there is a reward system here. This reward system is essential for everyone, whether you are healthy or sick, whether you are lazy or very active. You need reward in the reward system. You need reward for physical activity in ventral tegmental area. You need expectation of reward, the thing like you go to work even though you don't get paid until a month later, or in some countries a year later. But that's the nucleus accumbens that make you go. And the amygdala, the negative reward, the fear of snakes and spiders, etc. But while this system is automatic, this one is not automatic. This is what makes sense into our reward system. This is what can be changed. So if we want to talk brain plasticity, we don't talk the reward system. That's just the engine, the motor. But here, the cortex, the outermost 5 to 8 millimeters of the cerebrum of the big brain, that's what can be modified when we work with it. And that's what I'm going to talk about today. A picture like this sort of tells us that this area is a speech area. That is not quite true. It is, and there are networks for speech, and there is a concentration of neurons related to speech in that area. But fortunately, this network extends beyond the area. So if we get a plaque or a stroke or a tumor or something that changes either axons or neurons, dendrites, whatever, in a given area, we will see that this stops working for a while, but there's hope for rehabilitation. And the reason is we have the networks around it that can be strengthened when we use the brain. Because the brain is plastic. That means basically like the biceps here grows bigger when you use it. The cortex here becomes bigger when you use it. Some of you might remember the old smartphones, before the smartphones, the first cell phones where you sort of used your thumb to press on certain numbers in order to write an SMS. And there was actually a study out then where they gave people their first cell phone. And before that, they made an MRI. Then they worked with the smartphone, the cell phone for 2 months. And then they looked at the brain again. And what happened? The area, the cortical area, the motor representation in the left hemisphere of the right thumb grew. So basically, by using the brain, not only do you, by using your body, not only do you do physical activity, but you also do brain activity, and you see that the brain grows. So here we see an example, small synapse, training, big synapse. This is structural. This is functional. You see the signal of the first neuron, and out comes a very small signal on the next neuron. Now we train. We have a lot of common activity in the two neurons. And you see that this neuron now has small dots. It has changed. That's plasticity. This is Hebb's rule. Hebb said, what fires together, wires together. So it basically means that these are now closely connected. So the next time you get the signal in, like this, you get a big signal out. That is the effect of plasticity. What is the short-term effect of visual deprivation? So basically, 9 years ago, we did a study. We blindfolded a patient on the right eye. We waited 48 hours, and we took away the blindfolding. And now the question is, how sensitive is the brain when you blindfold an eye? So we look at the visual cortex, the area that's used for visual processing. And we used a coil, so an electrical coil. So we made a strong magnetic field, and that sort of activated the visual cortex without any visual input. The patient thought there was a blinking light. There was no light. There was only the coil. And now I have a question to the audience, so listen carefully. What do you think happens if you blindfold a person for 2 days? Will there be changes in the sensitivity of the cortex? And if so, do we need more current or magnetism, or do we need less? How many of you think that it will be unchanged? It's only 48 hours. None of you. Very good. So there's a change. What will happen? Will the brain need more current to be activated? Yes. None of you suggest that, but that's the answer. If you look here, you will see that up here we have the amount of current, and you see there's a small light here. Here's a great light when you get a lot of current. But already after a few hours, you will see that you need more. You need to go from 45 to 55% of max in order to activate the brain. So if you don't use the brain, it becomes lazy. Use it or lose it. A study that gave the Nobel Prize to Hubel and Wiesel, that's long-term plasticity. So what happens not only in 48 hours, but in a month or 2 months. They had kittens with 2 eyes. They closed the left yellow eye here, and then they looked at the cortex, at the ocular dominance in the cortex, and usually there are just as many yellow neurons looking at the yellow eye as blue neurons looking at the right blue eye. But if you blindfold an eye for a long term in the critical period of childhood, you'll see that there's very little yellow activity and a lot of blue neurons. Basically, that means that the left eye has become lazy. And that's why it's important that we keep on using our brain to the biggest extent possible. If we look at MS, we will see that there are several phases. I'm not very much into MS. I won't try to be a specialist, and I will try to focus on the clinical disability and the brain volume. And basically what you see here is that the brain volume goes down as the clinical disability go up. But are there any ways that we can try to keep brain volume? Because everyone loses brain volume. So as soon as you get a year older, well, your brain has shrunk a little bit. But you can try to counteract it, and that's what I want to talk about. So exercise is one example where you see the amount of exercise down here, and you see adjusted total brain volume, and you'll see that in all age groups there is an increase, maybe not so much in the lower age groups, but in the higher age groups, you will see that being physically active is very important for the brain volume. And brain volume is very important for our ability to do cognitive things. So you can also do focal things. So you can focus on doing a specific things, like reading Braille. Is it good to be good at reading Braille? Yeah, if you're blind, that's a good thing. Does that train all your brain? Well, part of it. And the important thing here is that not only do you see areas grow, but you also see areas that are better at picking up signal. So this is a SEP. A SEP basically means that you do stimulation in the periphery and you look at what part of the brain is involved. And after a year of reading Braille, you have a much bigger connection from the input to the area that does part of the processing. Okay, so now the brain is plastic. How does that relate to the good life, which is the other half of what I'm going to talk about? Well, what is good life? Well, you can ask, and retire at 55 wouldn't be bad, would it? That's in 2 years from me. Or all these things. But I think it's much better to try to look at this, to get balance in life. So the good life is a life in balance. What gives you the best meaning? Is that the job? That's for many people. That's religion. That's for other people. That's family and relationships. That's physical exercise. It's very different what we focus on. I believe that trying to go into one of these other slices of pie here would be a very interesting experience for many of us. I myself have tried to go into talk to people I don't know part of the brain. Basically, I sit down in our local community train and talk to people, and they just look at it and say, oh, he's crazy. But that's one way to get a balance in my life, because I am so busy with job and family. That basically means a lot to me. If we ask for numbers for quality of life, well, there is the Human Development Index, which is illustrated here. And that's one way. The Happiness Index is also very important. That's also something that has been discussed a lot in the media. But taking these quality of life measures into account, how do you get started? How do you get your brain involved in happiness? Well, you can sit down and think. You can be socially active. This is the thing I try to do in the train. You can sit down and do Sudoku, or read books, or do puzzles. By the way, I'm terrible at puzzles. There was on the national television, we did some study with autism a year ago. And I was competing with one of the autistic girls, and we had 10 minutes to do a 200-piece puzzle. She did 200 pieces in 9 minutes, and I did 11 pieces in 10 minutes. So there is room for improvement, and I think it's important to be aware of what you do with your brain, what are the possibilities, and what is difficult to do. But now it's your turn. Which one is the odd one out here? T, this one, yeah. Which one is the odd one out? Green circle. So basically our brain, like the monkey brain, it has a lot of capabilities. And what the monkey brain can do and we can do is that we can also look at faces, recognize faces, take other people's emotions into our brain and understand them, like poking your tongue at the monkey and pokes back, or do the same thing with children. Now I want you to look at this actor. It's a famous Danish actor. He had made 6 different facial expressions for you. And I want you to match the expression with fear, grief, happiness, disgust, anger, and surprise. So what is the first? Happiness. And the next one? Surprise. And fear. Grief, disgust, and anger. Very, very good. So this was easy for you. I'm not sure it induces a lot of plasticity in your brain. But what if you do this? This is much more complicated. Basically, this guy, he is 100% angry, happy, and 100% sad. And these have been made with facial morphing. These are like 90% happy, 80% happy, 70% happy, etc., etc. This is hard. This is hard for your brain, but it does train your brain. And training brain basically means that we go from here, being unaware, incompetent, then we experience that there's something to be trained, become aware, incompetent. The training is very hard, consumes a lot of energy, and when you do that, you will automatize acts. You will be don't think so much about how you walk or how you talk or whatever, and then you become unaware, competent. That's a goal in cortical plasticity, in learning, that you get over this. And when you get older, when you get a stroke, when you get an attack, some people will experience that they go backwards. So by being active and inducing a lot of plasticity in the areas that are important for the good life, it will be easier for you to withstand when the next attack comes. I will end up with this Gardner's 8 intelligences. So basically, Gardner, he had 7 intelligences, then he got another one, and then actually he got 9 towards the end. But I think these 8 are the most important ones. And up here we have word smart, logic smart. That's what most of us think about when we talk intelligence. But intelligence is so much more. Intelligence is also music smart, especially people smart. If you're not people smart, no, nothing else matters. Plasticity is the take-home message of my talk. Thank you.